Hey everyone, and welcome to this explainer. Today we are stepping into a vibrant, animated school of life to uncover exactly how the human mind actually learns. Picture a cartoon classroom, right? One where every abstract concept is brought to life with bold colors and dynamic action. We're going to take the brilliant, foundational concepts of educational psychology and map them out so clearly that you'll literally see the gears turning in real time. If you've ever found yourself wondering what goes on under the hood when a student learns something new, well, you are absolutely in the right place.
Okay, let's dive into this. Here is our syllabus for today's cartoon classroom. We're going to hit the basics of educational psychology, contrast growth versus development, explore Piaget's stages of cognition, break down theories of intelligence, and wrap up with personality and exceptional children.
All right, setting the foundation. Let's jump into Section 1, Basics of Educational Psychology.
So what is this exactly? Think of educational psychology as the ultimate teacher's toolkit. It's this perfect, beautiful blend where the rigorous, hard science of the mind meets the highly creative art of instruction. According to our sources, it's defined as the systematic study of human behavior in educational environments. And the goal here? It isn't just to passively observe. No way. It's to apply scientific principles to actively improve how students think, behave, remember, and ultimately learn. It's the essential blueprint that helps educators take a student and guide them into becoming a reflective, productive human being.
Moving briskly along, here is Section 2, Growth versus Development.
These two terms get mixed up all the time, so let's separate them. Picture our cartoon character again. Growth is when our character physically stretches taller and gets heavier. It's purely quantitative, structural, and most importantly, it stops once they reach maturity. You can measure it with a ruler or a scale. Development, on the other hand, is like that classic functional light bulb turning on inside their brain. It's qualitative, it's internal, and it represents a complete change in how their physical and mental organs actually function. And unlike growth, development is a continuous, lifelong process. As the saying goes, it runs from the womb to the tomb.
Stepping into the mind's cognitive workshop now, this is Section 3, Piaget's Stages of Cognition. You literally can't talk about learning without talking about Jean Piaget. He believed that as children experience the world, they actively build knowledge. To understand this, we have to start with schemas. Imagine schemas metaphorically as literal cartoon building blocks snapping together inside the brain. These are cognitive structures, or patterns of behavior, that a child uses to deal with objects in their environment. Every single time a kid encounters something new, they reach for these mental building blocks to try and construct their understanding of the world around them.
Now, what's really interesting about this flow is how everything connects. You've got those foundational building block schemas as your starting point, but what happens when the environment throws a curveball? The mind gets forced into an adaptation phase, desperately trying to find its balance, or equilibrium. And as this adaptation happens over and over again, it actually propels the child forward through distinct age-specific stages of learning. Let's zoom in on that adaptation process for a second, because it's driven by two very distinct mechanisms. Assimilation is like a character smoothly sorting a brand new colored shape into a mental box they already have. Boom, it fits perfectly. The new experience easily slots into a prior concept. But then you have accommodation. This is when the new shape doesn't fit at all. The character has to physically build a brand new mental box just to make sense of this wild new experience. Both of these are absolutely crucial for learning and keeping the brain in balance. And this brilliantly illustrates the result of all that adaptation, a strict staircase model of cognitive development. Notice how it moves step by step from sensory motor at the bottom all the way up to formal operational at the top. Piaget's big argument was that every single stage transforms the one that came before it, and you can't skip steps. A child has to climb this staircase sequentially, packing their earlier lessons into their newly upgraded cognitive toolkit. Let's walk down this timeline real quick. From birth to age 2, we have the sensory motor stage. This is where infants learn purely through their senses and motor actions. Lots of physical trial and error here. Next, from 2 to 7, the pre-operational stage kicks in, unlocking language and symbolic thought, though it's still highly egocentric. From 7 to 11, the concrete operational stage introduces logical manipulation of symbols. And finally, at 11 and beyond, they hit the formal operational stage, unlocking those abstract, hypothetical, complex cartoon thought bubbles. Okay, so having built this foundation of how we develop and how we learn, we really have to pause and ask a massive question. What actually makes a student intelligent? Is it just having a ton of those mental building blocks, or is it something more?
Welcome to the Superpower Training Center. This is Section 4, Theories of Intelligence.
First up, we've got Spearman's two-factor theory from 1904. I love this one because you can imagine intelligence as a literal superhero's power source. Spearman proposed that we all have this G factor, a universal, innate, general mental energy core. But to perform any specific task, you also need S factors. These are specific, variable abilities. It's like a superhero swapping out different gadgets for different missions, right? Your performance on a math test depends on your core G energy plus your highly specific S factor for math.
But actually, scratch that. Psychologist Louis Thurston totally disagreed with having just one core energy. He introduced the group factor theory outlining 7 primary mental abilities. Think of this like a character select screen in a video game. You've got independent stats for number, word fluency, verbal comprehension, associative memory, perceptual speed, space, and reasoning. Thurston believed these were distinct mental operations, so a student could literally have maxed out points in perceptual speed but lower points in reasoning. It's a much more decentralized view of brain power.
Let's move to our final classroom and see how all this builds together. Section 5, Personality and Exceptional Children.
Every single student's personality is wildly complex, and psychology gives us a few different lenses to make sense of it. Type theory categorizes people into distinct buckets, kind of like how the ancient Greeks classified temperaments by body fluids. Wild, right? Then there's trait theory, championed by folks like Allport, which looks at continuous characteristics like extroversion or agreeableness that drive our everyday behavior. And then, of course, the psychoanalytic approach. Picture Sigmund Freud's dynamic as a constant comedic cartoon squabble in the brain. You've got the pleasure-seeking id demanding immediate fun, the strict superego demanding you follow the rules, and the poor ego desperately trying to referee the match so the student can just function.
So the crucial point here is that because every mind has this unique blend of traits and intelligence factors, real classrooms inevitably feature exceptional children who deviate from the standard norm. They require highly individualized blueprints. Gifted kids need enrichment for their high IQs and creativity. Slow learners simply need an adjusted pace to succeed. Students with learning disabilities require specific, targeted teaching aids, and those categorized as delinquents require really focused, empathetic, emotional guidance. One size absolutely does not fit all.
Which leaves us with this final thought. We've mapped out the mind's building blocks, we've looked at superhero theories of intelligence, and we've explored the dynamic personalities within the vibrant cartoon classroom of our minds. But when we transition from this fun, animated theory into the very real, messy, and wonderful classrooms of the real world, are our educational tools evolving fast enough to nurture every single unique mind? It is the ultimate challenge for educators today. Thanks so much for joining me on this explainer. Keep learning, and I'll see you next time.